Okay, energy diagrams. So there are a couple different types of energy diagrams. I'm going to mention the simple type first, where you could, for instance, make a plot of your total energy, your potential energy, and your kinetic energy. Let's use some different colors for this. So potential and kinetic. What conservation of energy will end up telling us is that the total energy should stay constant at any moment in time, but the potential energy and the kinetic energy can interchange with each other so that you still end up having a constant amount of total energy. Now, this would be in a case where there's no external force and no resistive forces. If there were external forces or resistive forces, you could actually see a situation where the total energy changes over time. So if you see something like this, for instance, with the total energy versus position or time or what have you, then this indicates a loss of energy. And that would usually be the result of resistive forces. All right, that's kind of the simple case. The more interesting case is what happens if you just consider the potential energy, because remember, the potential energy relates back to the force. So if we look at the potential energy versus a position, we can look at how that potential changes in different places. Matter of fact, I want to change that a little bit. It's good to start with, but I do kind of want the flat section to do something different. All right. So there are several interesting points in here. Remember that the force is basically the negative derivative of the potential energy with respect to position, which means you've got the opposite slope thing kind of going on. But if we take the derivative, there are, in this case, special points. So places where f is equal to 0, which means slope of du dx equals 0. And you can see a few such places in here. Each of those has a special particular meaning. This one is a local maximum of the energy curve, and it would be a point of unstable equilibrium. Let me change to a more visible color for this. How about yellow? So point of unstable equilibrium. And down here at the bottom, that would actually be a point of stable equilibrium. Oops, missed the N. This right here is sort of a weird case where it's nice and flat. That would be a neutral equilibrium. All right, let me define those a bit more carefully for you now. Stable equilibrium is a point where an object, if bumped slightly, will return to its original position. Let's think about the way this works for a moment. We've got a negative slope here, which means we have a force that acts in a positive direction thanks to the relationship. That means if something moves towards the negative side, it gets squeezed back towards the positive. If it's squeezed towards the positive, we see a positive slope, but oops, we've got a minus sign. That means the force will be in the negative direction and squeeze it back towards where it was. Vice versa. Unstable equilibrium. That's a point where if the object is disturbed, it will tend to run away from that point. Consider the point up here at the top. On one side, we have a positive slope, which means there's a negative force. If it gets bumped in the negative direction, it now experiences a force in the negative direction, driving it even further away. Similarly, we have a negative slope on the other side. Well, with the minus sign here, that means the force is in the positive direction. If it gets bumped in the positive direction, it goes flying off in the positive direction. Lastly, neutral equilibrium, you bump either way, it doesn't result in a force. So if you bumped the ball sitting on the top of this hill, it would tend to just roll along the hill until it hits a point where that changes. So you'd be acting in a case where there's no net force acting on you, at least not due to the potential that we're following here. It's pretty cool stuff. We've got one question in the homework that will relate to these ideas. It'll just ask you about stable equilibrium and unstable equilibrium points. Yeah. So I think that's it for energy diagrams. We're going to stop here and come back with some more videos later.